enhancing climate resilience through advanced transmission asset management center. So please come, and we agreed on, I'll disclose, we agreed on 10 minutes. So when I come, it will be 2 minutes before the 10 minutes are over. Karibu.
Prof, I want to assure you that you will not have time with me, you will not have problem with me, because first I came here expecting that I'll do a panel discussion based on our just recently concluded collaboration with the Moi University. So our president, Engineer Sharma, the DVC representative of Moi University, our convener, who is also my thesis professor, Professor Makoa, all staff from Moi University, my colleague in the energy sector, KPLC, KPC, REREC, and KETRACO. Good morning. As I said, I didn't prepare for presentation because I just assumed that we shall have a panel discussion. When I was approached to present this topic, I was very willing to do it, given that I am the guy who has been in operation and maintenance for the longest. I have experience over 20 years in operation and maintenance. And I'm the one who is affected mainly by the climate change in the recent past. So I speak from experience. I speak from challenges that I do face. As a general manager in charge of system operation and power management, I'm basically the one in charge of all the entire transmission network, plus all associated transformers in KETRACO. And when you talk of the infrastructure in KETRACO, you are talking of a total length of circuit that spans 10,606 kilometers. We have a total of 10,500 towers, the one that you see, steel towers, which are served through 800 bays. It may sound a bit difficult to understand, but I know my brother, Engineer Owen, spends a lot of time in bays. KETRACO was established in 2008. And its mandate is to plan, design, construct, operate, and maintain high voltage transmission line that involves the Kenyan grid, and also has a very huge task currently of interconnection in Africa. For the information, our president talked about Tanzania. We are soon, in the next 3 months, we are commissioning Kenya-Tanzanian line. But for your information, engineer, they are so eager for the line because they are going to import power through our line, not export. They don't have enough. They have signed a PPA contract with Ethiopia, so the power will be flowing through KETRACO line, and we need to provide very resilient and reliable line for our brothers in the southern part of our country. So we operate such kind of network, but the challenges that we have had in the last few years are many. One of them is climate change. We have also been faced with some level of cyber attacks. We have a very aging infrastructure. We don't have a system for asset data management. We have resource constraint, and as you know, I'll refer a lot to the president because he talked more of electricity more than the roads and other issues, which was part of his discussion today. He never talked about some issues including energy, roads, water, and housing. He said more about electricity. So when you talk about constraint in terms of resources, for us to have a system that meets the requirement of our customers, that meets their passion in several other strategic for this country, we need to invest a lot of money. The problem is We are not in a position to increase tariff any moment. You know, Kenyans are very keen nowadays on anything that adds a shilling to their cost. So those are some of the other challenges, our operation challenges, and also meeting our performance target to the ministry and IPRA. So we are guided in our strategies through a number of issues. That is Vision 2030. There is the National Climate Change Action Plan for Kenya, 2018 to 2022. There is the Kenya National Determined Contribution under the Paris Agreement. And of course, we operate under the Least Cost Power Development Plan. So when I was called for this meeting, it was in coincidence with a paper I was doing to a management on funding. And the document was speaking to what we are talking about today, because we are talking about integration of digital technologies. Given the number of kilometers we run, and given the number of the changing weather patterns, we are not able to do it with the current resource. We have a complement of almost 530 employees in KETRACO. Most of it are under my directorate. They are almost more than half are in the sector of system operation and power management. But if you see 10,000 kilometers, you see 10,000 number of towers, you see 800 bays, and you see a climate that is changing every day. And I want to give you a very good scenario of the climate change effects on our transmission line. Some few years ago, the Sabaki River changed its course by almost 3 kilometers. So towers that had been designed by civil engineers, I know Kipkemoi will talk about, which was very adapting to the existing environment that time, could not withstand a changing course of the river. Several of those towers went down, and until today we are struggling to have permanent towers. Having a permanent tower in a waterlogged area with moving water, Kipkemoi will tell you, is quite expensive, and that is why I was talking about infrastructure. That is one of the events. The other event is strong winds that bombarded the Longonot Tower, affecting the transmission line that evacuates 300 megawatts power from Lake Turkana to Suswa. That one was a climate change that was not anticipated during design stage. Several other things that has happened that have caused national blackout sometimes are related to the environment but not operation and maintenance of the system. So this paper I did was titled Enhancing Climate Resilience Through Advanced Transmission Asset Management System in Kenya. This paper was done basically for the improvement of the system and the way we operated. And what does it entail to have that system in place? First, with that system in place, the advanced transmission asset management system, the overall goal is, of course, to enhance the resilience, reliability, and efficiency of the grid in the face of climate change through an advanced system that gives you uses more digital, more artificial intelligence to prompt you on what my brother Owen was talking about, predictive maintenance. You cannot have a predictive system that is not aided by AI or some of digital intervention. So what is in it that I call Advanced Transmission Asset Management Center? The structure that I've proposed for KETRACO is a main transmission asset management center that will be based in Nairobi. That will be an asset center that will incorporate all the data to make decisions as per the changing weather patterns and the required intervention in terms of maintenance. And also to address the issue of cyber security. Because when you depend on one center, any attack on that center will cause a national blackout. It causes confusion. I thought I had a lot of time. So with a backup system in Suswa, and then it will have regional transmission asset management center, We shall have pilot site for that in Nairobi, Suswa, and Isinya. What is in it that I was calling for the support, and that is where technology comes in, the one that we are talking about today. One, the support of Climate Resilient Transmission Asset Management Center. One of them, it will have diagnostic analysis. It will be able to analyze the current asset and look at the climate vulnerabilities. Second, it will have a climate change focusing and design of resilient structure. Third, it will have a climate resilient design standards. And our president talked of standards for us to be able to measure ourselves for transmission asset. After that, in the transmission asset center, the main one, the main center will be, of course, bomb-proof and all other issues. But in that center, we shall have a development and implementation of a SCADA system, an EMS, energy management system, which is integrated with an asset health monitoring feature, a feature that is fixed in our asset to monitor the health of the system at every one point. We shall have an installation of sensors and monitoring equipment on critical transmission assets. That is mainly the transformers and maybe some lines that are very critical because it's very expensive. We shall also have an automated fault analysis system called FAS. And this one will be integrated to a dashboard that is called human-machine interface, a dashboard that you can intervene at any point on the system. Also, there will be an element of environmental monitoring and evaluation at every given time. So that investigation will be on current environmental practices, and then we shall develop tools for monitoring and evaluating environmental impact during operations. That is on every operation, you look at the environment. In terms of artificial intelligence, my brother talked about drones. I'm almost done. And one of the issues about drones is that a drone cannot help you by itself. But if you have an integrated artificial intelligence that talks to the National Asset Management Center, they'll have cameras with intelligence. They'll do infrared. They'll do any measure and variation. They'll also do climate ground change. If they go today, they take a picture. Then after 3 months you come, he'll superimpose the old picture with a new picture and prompt you that there is a slight movement on ground. Those are the intelligent systems that we are going to incorporate. Finally, what will be I don't want to go about the implementation. I want to see what are the benefits of this. One of the benefits will be adapting to climate change. The Transmission Asset Management Center will have resilience infrastructure that adapt to the climate-related risk, thus improving efficiency. It will also reduce the transmission losses, and that will help more of our Kenyans in terms of reduction of bills. The project also will promote sustainability by enabling environmental sustainability by enabling more integration of renewable, and all other benefits including poverty reduction, energy access. We shall be able to provide an efficient regional integration, and the center also will help in technology transfer, and we shall have a disaster risk reduction mitigation measure that is purely based on AI, digitization. All equipment will be retrofitted with an intelligent system, IEDs, and with that center, a lot of benefit will be accrued. So what I want to conclude is that for us to meet the requirement of the energy sector, for us to meet what is put in IPRA, without the integration of digitization system, without use of technology, we are not going where. We are not going to meet our measures. I just want to speak to the standard that you talked. We operate on a very clear international standard. We have standard called CAIDI, Customer Average Interruption Duration Index. We have system average frequency interruption. We have something called average number of false transmission outages. So all those can be, first can be captured very well so that even you, where you are, Engineer Sharma, you can log in and see what are the parameters that this country are operating in terms of those standards. I want to finally thank specifically Moi University, generally Moi University, but specifically Magoa, because what we need as a country is to integrate the academia with the industry. Through the 2 meetings that you have had, Professor, I've carried away with something, I've gone home with something, and if we can support IEK and other players in the energy sector, if we support the initiative by Moi University, we shall be able to improve the system. Most of these things I've done is more of academic, and maybe it's the knowledge that I've got through Moi University and other institutions. So generally, I want to thank all of you, and my prefect is standing. Let me close there. Thank you.